NATO called it the Flogger. When it appeared at the Domodedovo Air Show in 1967, Western observers understood immediately what it represented: a Soviet variable sweep wing fighter built to close the capability gap the MiG-21 had left open. It could sweep its wings from 16 degrees to 72 degrees in flight. It carried the first look-down/shoot-down radar ever fielded on a Soviet production fighter. It was armed with beyond visual range missiles at a time when most Western pilots were still fighting within visual range. More than 5,000 were built, making it the most produced variable sweep wing aircraft in aviation history. And by the 1980s, the MiG-23's accident rate in the Soviet Air Forces averaged 12.5 losses per 100,000 flying hours. In Hungary, the figure reached 24.3 major mishaps per 100,000 flying hours. In East Germany, 20.4 losses per 100,000 flying hours. In Bulgaria, 18 losses per 100,000 flying hours. The aircraft that scared NATO was killing Warsaw Pact pilots at a rate that made it one of the most dangerous jets its own operators ever flew. The question this video is built to answer is how both of those facts, the genuine tactical threat and the catastrophic accident record, came from the same design, and what that tells you about the gap between what an aircraft promises on paper and what it delivers under the conditions its operators actually face. Let's get into it. The MiG-23 was designed because the MiG-21 had run out of room. The MiG-21 was fast and agile, but its primitive radar, short range, and limited weapons load restricted it to a point defense interceptor role that Soviet planners recognized as inadequate for the evolving threat environment of the late 1960s. The specifications for its successor were ambitious to the point of contradiction: greater speed, greater acceleration, improved maneuverability, better low-speed handling, longer range, heavier payload, and a new radar capable of detecting targets against the ground. The solution to that list of mutually exclusive requirements was variable wing geometry. The MiG-23 would sweep its wings continuously between 16 and 72 degrees, with three primary positions marked as standard settings: 16 degrees for takeoff and landing, 45 degrees for cruise, and 72 degrees for high-speed dash. The sweep mechanism was heavy, mechanically complex, and structurally demanding. It added weight and maintenance burden to an airframe that was already being asked to do more than any previous Soviet fighter. The prototype, designated the 2311, first flew on April 10, 1967. Production started in 1969. The first production variant, the MiG-23S, entered Soviet Air Force evaluation in 1970 and reached full operational service by 1973. The production total across all variants eventually exceeded 5,000 aircraft. The MiG-23 experienced significant challenges during its early development phase, with prototypes and initial production models prone to control instability, particularly at high angles of attack, leading to departures from controlled flight and multiple accidents between 1969 and the early 1970s. This instability arose from the variable sweep wing design's interaction with the aircraft's aerodynamics, exacerbating issues like unintended rolls during slips with wings in the forward position, departures from controlled flight in a jet fighter during the period when pilots were still learning its characteristics and the design was still being refined. Those departures were not edge case emergencies. They were accidents waiting inside a normal flight envelope that pilots were occupying every day. The engineering problem behind them was structural. A variable sweep wing changes the aircraft's aerodynamic center of pressure as it moves between positions. Managing that shift requires precise interaction between the wing sweep mechanism, the flight control system, and the pilot's inputs. In the early MiG-23 variants, That interaction was not yet fully resolved. The result was an aircraft that behaved predictably in some configurations and dangerously in others, and that the pilot could move between those configurations by adjusting wing sweep during a maneuver. Throughout the 1970s and early 1980s, Soviet pilots continued to train and operate the MiG-23 in the same inflexible manner as the MiG-21, a high-speed point defense interceptor closely guided by ground control interception. That operational doctrine compounded the aircraft's early instability problems directly. Pilots flying rigid GCI-directed intercept profiles were not developing the stick and rudder feel for the aircraft's variable characteristics. They were executing program procedures in a machine that punished procedural flying with the same aerodynamic indifference it applied to any other input. The accident rate that followed was a joint product of design and doctrine, and the Soviet Air Forces paid for both simultaneously. Now here's the operational record that documents the full picture, including the incident that is the most precise summary of everything the MiG-23 was and was not. On July 4th, 1989, Colonel Nikolai Skuridin of the Soviet Air Forces took off in a MiG-23M Flogger B from Bagic Air Base near Kołobrzeg, Poland. Barely 41 seconds after takeoff, the engine's afterburner failed, causing the jet to lose altitude. Believing the aircraft was doomed, the pilot ejected safely at roughly 150 meters above the ground. Unexpectedly, the MiG regained power, climbed, and continued flying, now pilotless. The unmanned aircraft left Polish airspace, crossing into East Germany and then West Germany, where it was intercepted by a pair of US Air Force F-15 Eagles. The F-15 pilots confirmed the MiG had no pilot. As the MiG crossed into Dutch airspace and then Belgium, the escorting F-15s were instructed to shoot it down. But as the MiG ran out of fuel, it started a slow turn south. After traveling roughly 900 to 1,000 kilometers, the MiG ran out of fuel above the Belgian countryside, lost altitude, and crashed into a farmhouse near Belgium, south of Kortrijk. Inside the house was 19-year-old Wim de Leer, a computer science student who had stayed home after exams. He was killed instantly. The Belgian government made a formal protest to the Soviet Union regarding the lack of notification as to the danger the aircraft posed to the civilian population. The USSR paid $685,000 in compensation to Belgium. A Soviet Air Forces fighter, built to threaten NATO airspace, flew 900 kilometers, unmanned, through the heart of NATO Europe. Recognized as friendly by Warsaw Pact radar systems, left to fly by NATO pilots who could not safely shoot it down over densely populated territory, and killed a Belgian civilian in his own home. That incident did not define the MiG-23, but it illustrated, with a precision that no statistics can match, what happens when a mechanically complex aircraft with documented reliability problems is operated without the maintenance culture and training depth that complexity demands. The MiG-23 MLD, introduced in the early 1980s, was the variant that finally resolved the handling problems the early production aircraft carried. It was not until the widespread introduction of the MiG-23 MLD that Soviet pilots began to use the MiG-23 as a true air superiority fighter. The MLD incorporated aerodynamic refinements, wing leading edge extensions, and structural corrections that addressed the departure from controlled flight problem that had characterized the early variants. Exercises showed that when well flown, a MiG-23 MLD could achieve favorable kill ratios against the MiG-29 in mock combat by using hit-and-run tactics. That result, a corrected MiG-23 MLD competitive against the MiG-29 in the right tactical scenario, is the answer to the question this video opened with. The aircraft that scared NATO was not a myth. The aircraft that killed Warsaw Pact pilots was not propaganda. Both were true simultaneously because the MiG-23's design represented a genuine capability advance that its early production variants, its maintenance infrastructure, and its operational doctrine were not ready to support. The variable sweep wing gave the aircraft a performance envelope no fixed-wing Soviet fighter had previously achieved. The mechanical complexity behind that envelope required a maintenance standard and a pilot training depth that the Soviet air forces and their Warsaw Pact allies delivered inconsistently across the fleets that flew it. The accident rates in Hungary, East Germany, and Bulgaria were not identical to the rate in the Soviet air forces because they were all flying the same aircraft badly. They were higher because they were flying the same aircraft with less training, less maintenance support, and less institutional knowledge of its specific failure modes. The MiG-23 did not have two reputations. It had one reputation that applied differently depending on who was flying it, how they were trained, and how rigorously the aircraft was maintained between flights. The Flogger that frightened NATO analysts in 1967 was the same airframe that killed its own pilots in the 1970s. The MLD that achieved mock combat parity with the MiG-29 in the 1980s was the same design, corrected by the engineers who had spent a decade documenting what the original had gotten wrong. That is the complete and documented answer. If you enjoyed this video, please like, subscribe, and turn on the notification bell. More deep aviation stories are coming.